This is the second part we call hydraulics. Okay, hydrology, hydraulics, right? Hydraulic and hydrology. Hydrology is the study of the rain, water. Okay? Hydraulic is the study of providing a provision of sufficient structures to cater for the water that coming from the hydrology just now. Just now the hydrology, the Q was CIA, right? So in hydraulic analysis, now that we are going to provide the drain, I just mentioned drain, there are many more such. There are another two common formula, or you can say one, which is the Q equals to VA. Tadi QCIA, this is hydrology, hydro. This is hydraulic. Right? And what is V and what is CIA? Just now we already discussed what is CIA. The V is the velocity of water flowing in, for example, in a drain. Water flow. How fast is water flow from this point to that end? Let's say this is what? About 10 meters. So how many seconds is required for the water to flow from here to there? Maybe 3 seconds. So 10 meters divided by 3 seconds. So about 3 meters per second. Right? What is A? Okay, this A is different. Just now it was the catchment area. Now the A is this one here. Let's say this is a drain, right? You have a rectangular drain. So the A is this is the area of water flowing. So this rectangle here, that's the A. The A for that water flowing. Okay, so for us to be able to use this formula now, tadi yang ni CIA we have just discussed what is C and IA, where to get the ini. But for hydraulic, the A, I just told you just now, the A. The velocity is V equals to 1 over N R to third S 1/2. Does everyone got calculator? No calculator these days. I hope you can bring your calculator during exam, because I don't think they allow you to bring on your handphone to do calculation. So during exam this year, I need each of you to bring your own calculator. Tak boleh pinjam orang sebelah. Tak boleh. You bring your calculator. Yeah, something like that or something like this, right? To do the calculation, because now you can expect there will be some calculation in your exam. Because I'm telling you to bring the calculator. Okay, but before that, what we call it, the water flow. We need to understand the water flow characteristic in a drain before we can provide suitable drain size or type to cater for the water flowing from the rain just now. So what we need to know, these are flow area, which is this one, the A just now, okay? The flow area. We need to know the flow area. That can easily be calculated, right? You know the size of the drain, the rectangular especially, just width and height, so you get the area. The second one is wetted perimeter. Wet perimeter. Wet perimeter is called, you see this formula here? P perimeter. Wetted perimeter is P, and then you have R, hydraulic radius. Because in this formula you ada R kan? So R is the radius. Dia bukan radius ni. It is called hydraulic radius. So hydraulic radius is R in this formula is equal to A, which is the area just now, right? Divided by P. So you can see this formula here. R equal to A divided by P. Right? So then you know what this R here. V is, remember, we're trying to find the velocity here. V velocity equal to 1 over n. I'll tell you about n afterward. S, what is S? I think we have that formula in the next slide. S is the slope or gradient of your drain. Remember, if your drain is flat, the water will never flow. So it has to be lower over there, slightly higher here, and the water can go over there, right? So that is the gradient. So what is the difference between the level over there and the level here? It has to be slightly higher, slightly lower, then the water can go. So, but whatever it is, you need to know these three things. Flow area, wetted perimeter. Okay, where is the wet perimeter? Or P. The wet perimeter, you see this dashed red line? The length of, total length of this dashed red line. On the left side, on the bottom, and on the right side. Not on the surface. Because this surface is not touching any structure. It's touching air. So it's not counted as wet perimeter. So perimeter that is in contact with water, which is this one here, down here, and up there. So surface not counted. So that is wet perimeter. Where the contact is wet. The air cannot be wet, right? And lastly, the hydraulic radius. Okay. So the hydraulic radius is which is R, which is equal to A, the area, divided by the wet perimeter just now. So that is R. So this is a fundamental equation for us to be able to determine the characteristic of the water flowing in any drainage system. So this formula, just now the formula was called what? Rational formula, right? Now it's called Manning formula. Manning. So the Manning formula is this one here, or the one that you see there. This is what we call Manning formula, where you have velocity equals to 1 over n r2 s1 half. S1 half means square root of s, right? S to the power of 0.5, that means square root lah. Tapi dia guna 1 half. So practice using that in your in your calculator. Nanti macam mana nak buat ni? S setengah je nak buat ni. You must know, right? Afterward kita buat practice. Pas ni. Sama juga R2 third ni. R to the power of 2 third, right? How do you do that? I mean, 2 kali ganda 10 kira tanggal itu. Nah ya, 2 third you bagi je lah, dapat 0.6. You guna power 0.6. 0.66 lah kan. Okay, and then so this is another formula is the Q equal to VA I mentioned just now. The Q again. Before the Q, CIA, we have gone through that, the hydrology. So this is the hydraulic formula. The QVA and the V goes to 1 over N. And of course, because this is V, kan V ni boleh masuk dalam ni. So you can expand the formula like this. Right? No. This is another formula. You can, V you can replace by this, you can expand the formula straight away, in case you need to calculate the Q. But of course you can calculate the V first, and then you calculate the Q. The N, right? The N. You may be asking, apa? N tu apa? N tu actually what we call Manning coefficient. Coefficient. Macam tadi kat C, coefficient. This one is Manning coefficient. This Manning coefficient depends on the type of drain or the surface of drain. If it is very smooth, the coefficient is very small. It's very rough, the coefficient is higher. So what is the most common coefficient that we use for drain? Most of the time we use concrete drain. Concrete drain, the coefficient is 0.013. So that's N, right? You're talking about somehow you have a swale or grass channel like that. What would be the N? Let us check. meaning coefficient n. So, concrete 0.11. Just now I mentioned what? 0.013. So I took the maximum. Right? So recommended 0.011. But of course you can. If this is very smooth like this, probably 0.011. But sometimes, parit kita kan, semua dah, you letak tangan gosok habis. So that is very rough. So that is 0.013. Short grass, so 0.15 up to 0.2 grass. So meaning they are a lot more resistant of flowing. The grass will resist the water flowing. So that is why the N is higher. Right? So it depends. The N in that formula will depends on the type of drain surface. So okay. Okay, now we have nak buat exercise je okay lah. Let me see, what's the time now? We are about halfway now. 3. Alright. Let us do some exercise. Okay, you can take out some paper and then I will go and check. Okay, what we want to do now is to calculate this Q from hydrology. To calculate the Q from the water that is going to come out this door. Right? So I will give you the I already draw the second exercise actually, tapi tak apalah. We'll start with the first one first. Okay, now remember for us to be able to calculate the amount of water that is coming out from this door, we need to find what we call Q. Q ataupun runoff, right? Runoff, which is equal to just now CIA. Alright. Since we are talking about road projects, let's say the catchment area of a road. Okay, we have a road like this, right? And then it turn right and then straight again. So this portion here, let's say 150 meter, right? 150 meter. So the width of the road on the left is, let's say it's just a rural road. It is 3.5 meter. Of course, on the right also 3.5 meter. But since it is turning right, so all water will go this way, right? Go to the right. And then you need to provide drain here. Drain. So, in order for you to later on to size the drain, you need to know the amount of water that's coming down. So now, 3.5 up here, 3.5 below. So you need to calculate first catchment area. So meaning this catchment. So what is the catchment? A. Right? So you can calculate the catchment now. So 3.5 by 3.5, 7 multiplied by 150. So that's catchment. Right? Area. That is in meter. But remember, you need to convert to hectare or kilometer. It depends which formula you want to use. If you want to use kilometer, then you can convert the area to kilometer square. If you want to use hectare, you can use you convert the meter square to kilometer square, or you can modify the formula so that you can use meter square. You can have your own conversion factor directly for meter square. Either one, right? So everyone has got A? Have you got A? Area? Lebar jalan 3.5 one side, the other side is also 3.5, so total 7 lebar dia. Right. Length dia 150. Yeah, dapat? Yeah? Yeah, again? 150 length meter. And then you can convert to kilometer square or you can convert to hectare. It's up to you. Okay. Have you got it? So senang je, you tengok so you have 7 meter kali 150 kan? So apa? A equals apa? Anyone can tell me? 7 by 150, 700, 1050 meter square. 1050, right? So it is 1050. 1050 meter square. And someone can convert it to hectare and kilometer square. Okay, those of you on my right side, convert to hectare. Those of you on the left side, convert to kilometer square. We will compare the answer afterward. Over here, in what are it? in kilometer square. You guys here, in hectare. So, you check your answer later on. So I'll give you the answer now. In where was my pen? In kilometer square, it is 0.00105. In kilometer square, right? 0.00105. In hectare would be similar. Hectare is 0.105. 0.105. Because one 10,000. 1 hectare is 10,000 meter square, right? That's the conversion. 1 hectare is 10,000 meter square. 1 kilometer square is 1 to exponent of 6, meaning 1 million square meter. So, okay, so that's the answer you should get. This is the area in meter square. This is the area in kilometer square, right? Okay, now you choose which formula you want to use. Q equal to CIA divided by 360 or 0.278 CIA, depending on which formula you are using. Formula that use area in kilometer or formula that use area in hectare. Okay. Now Now we have got the A, this one here. What is I? Okay, let us look at the chart. Alright. Let us look at the chart. Okay, this chart here. Alright. Okay. You are going to design a roadside drain. So the roadside drain ARI will be, alamak tak nampak lah colour dia. So we use slightly lower. ARI 5, patutnya 10, okay? Patutnya 10. ARI 5 is in blue color, which is this one here. ARI 5, the second line here, 5. And remember, kawasan tadi kecil je kan? 1050 meter square, that is about 2 acres. So now we assume the time of construction or storm duration would be of berapa minit tadi? With a minimum of not 4 minutes, 50 minutes. What was that? 10 minutes, right? The storm duration is 10 minutes. Sorry. So what would be the intensity? So you need to look when your storm duration is 10. This is 100. This is 1,000. This is 10,000. This is 10. This is a log chart, logarithmic chart. So that's why it's 10, 100, 1,000, 10,000. So 10 minutes here. This is 100 minutes. duration. So you take 10 minutes, your duration, you go up, touch this curve, and you go to the left. That is about, this is 100, this is 200, right? So the I is about 150. You can see. So that is 150 mm. So the I is about 150 mm per hour. Alright? Okay, now you have got A and I. A you have got in hectare and also in kilometer. So now, what is the C for road surface? Kita tengok tadi, different type of C for land cover. What is C for road surface? Can you go back to the chart, to the what is the C for road surface? Yeah, the C is 0.95. Okay. So C is 0.95. Now you can calculate what is the Q. So everyone can calculate your Q based on whatever area that you decide to use formula. Sama ada you pakai formula kilometer square or pakai formula hectare. Alright, you should be able to get the Q. And then you need to let me know the Q. Alright? What is the Q? Dapat di mana? Apa? Huh? 0.04. Okay, anyone got different answer? 0.04 meter cube per second. Anyone got different answer than 0.04? You should be able to get the same answer. Yes? Well, you can keep 2 decimal places. So what have you got? Yeah, same thing. So that means the Q is 0.04 meter cube per second. The Q. Can you imagine what is the amount of 0.04 meter cube? If that is about 1 meter cube, this is the height of this table. Dash is about 1 meter. You go 1 meter over there, 1 meter, and you got 1 meter cube. And then that is 0.04. That is about 1 in 20. Maknanya one portion of the 20 divide by 20 of this 1 meter cube. That is about satu baldi lah. Satu baldi per second. Satu baldi of water flowing in your drain per second. Right? Satu baldi. Tak banyak lah. Satu baldi banyak lah. About this big. In 1 second. Flowing like that. So later on we will use this Q to decide what is the size of the drain. Right? In our second exercise. We will find what is the size of the drain based on the hydraulic formula that we have just discussed just now. Okay.